Let's start the new theory, torque acting on the rigid body. As we have discussed earlier, the rigid body without considering its motion, but from now we will see also the reason behind the motion of rigid body. So for that I am taking a small case of rigid body. So here you can see the path of rigid body or the figure of rigid body in which the particle P is shown and this rigid body is rotating about the fixed axis that is OZ, and if we see that this is a system of n particles, because this particle P at Rn position vectors, that means there are some other position vectors and we are expanding our analysis to the n particle theory. So again, for particles positions R1, R2 up to Rn, and the force which is acting on this system of particles are F1 vector, F2 vector, and so Fn vector. So with the help of this, means the value of Rn and the value of Fn, I can find out the torque acting on particle P. Is given by tau vector is equals to, or for subscript n I am using because this is for nth particle, so that is equals to Rn vector cross Fn vector, and we know that this vector product in terms of the determinant is given by I cap, j cap, k cap, here comes xn, yn, zn. So this is basically the lines of Rn, or we can say the components of Rn, and here we will see the components of Fn. So the first component is Fnx, here Fny and Fnz. So let's simplify this determinant. So we will get tau m is equals to I cap into yn Fnz minus zn Fny minus j cap into xn Fnz minus zn Fnx plus k cap xn Fny minus yn Fnx. So this is the value of torque which is acting on the single particle P. But for the entire body, if I want to study about this system, then I just have to put the summation in addition to this equation. So my torque on the entire body is given by tau n. Vector notation is as it is, summation over n into the bracket yn fnz minus zn fny into I cap minus zn fnx minus xn fnz into j cap plus xn fny minus yn fnx into k cap. So this is the value of torque on the entire body, and this equation you can use for solving some application or illustration. So I am giving this equation as number 2. Now, when a rigid body performs the rotation, or we can say a rotational motion, along the z-axis, then what happens? Then the z component of the torque is responsible. Then you can see in equation 2, this component will be responsible for the rotational motion. So here we have considered the z component, and so the z component of torque is responsible. That means tau z is responsible. Similarly, you can think for x and y. If the rotational motion was along the y-axis, then the y component of torque is responsible for rotational motion. Similarly, for x-axis, you can further expand. As a general case, if the unit vector of the rotational motion is n cap, then what happens? Then the n cap component of the torque is responsible for rotational motion, because there is no any other axis are responsible for the motion. Then you can consider this unit vector component as responsible for rotational motion. Now, to produce rotational motion, now see the dynamics has been started. To the rigid body, some external force has to be applied, because the resultant internal force remains zero in the case of rigid body. Also, you can apply this external force not on all the particles, but in some of the particles you should have to apply this force. So I am writing here the external force to be applied to some of the particles because the particles are relatively moving to each other, or we can say the relative distance between these two particles of a rigid body is constant, and so the torque should be produced by applying the external force to some of or to any one particle only. So by applying external force on any one particle, then the entire body will affect the torque. So this is one good advantage of the torque, and this is only the reason from which rotational motion exists. Starting the new article, physical interpretation for the definition of torque. So we will now understand each and every property and the characteristic of the terms which are arriving into the definition of torque. And here I start the analysis of this particular article by means of one force acting on the rigid body. So here, as you can see from the figure, the force F is acting on a rigid body. And one more thing which you should have noticed over here, that this force is perpendicular to the plane of axis. And these axes are the rotational axis. Here the OP vector is showing the position, and here we have considered O as the reference point. Here the angle between the force F and R is theta. And also the components of F are in the x-axis as well as in the y-axis. Fx I cap plus Fy j cap, where the value of F or the component of F in x direction is Fx cos theta, and in the y direction it is sin theta. But here the magnitude of force in x and y is the same, because in the rigid body the force acting on a particle and the force acting on the system of particles are having the same values, because there is no change in the positions of particles. Now we will see the components of force F parallel to the rotating axis, that means F cos theta. Here in this particular case, the product of, suppose I am considering this as a Fx, so the product of R and Fx does not produce torque. And also, as it is not producing the torque, so it is also not producing the rotational motion. So there is no meaning of the parallel component of force. Now let's move on to the perpendicular component. So the perpendicular component of force F is equals to Fy, which is having the value F sin theta. Now this component will produce the rotational motion. And here if the magnitude of force is more, then this force becomes more effective. If the value of F or the magnitude of force is increasing, then the actual value of force will become energetic. Similarly, if you consider the position vector of the line of action of force is more, then also the resultant force will be more energetic to produce the rotational motion. So, the force is responsible for producing resultant rotational motion. And if you not consider that only force is responsible, but in addition to that, this position vector is also meaningful, and hence we are writing tau is equals to R cross F. So torque is the measure of the effectiveness of the force in producing the rotational motion. So this is about the physical interpretation, and now we will see one important property, that is couple.